I like this effect. I wonder what that 2 is about. Doesn't matter. Okay. I want to finish what we started yesterday. Let's see if we can figure out how to get cirtcom 2 to work out. Because right now it's breaking. Firstly, we need to replace W and in here. Or, yeah. Switch. We need to switch W and in. The reason is because we're thinking of in as the variable. W is fixed. In, of course, is the case-based data. So when we do the adjoint, here out is equal to some function of in, and that particular function and that's it. Like W is considered fixed with respect to this function. Okay, so I want to try and get circular convolution working. Circular convolution 2, I would have thought this would have worked, but it didn't, and so what? All right, and we were remembering that we realized that the origin for flip and the origin for convolution are different. So what do we do there? If I'm right, if I made everything odd, if I made all the sizes odd, and it crashes. Oh, adjoint test failed. Okay. So that is not the only issue. And boy, oh boy, is this tough. Especially nerve-wracking because I'm streaming. Without the shifts, the origin for the FFT is the first element. So maybe that was the issue. I forgot the 2's. Hey! Hi, Daniel! Protost is back online. Awesome. Using Starlink internet on a flight to Hawaii. Starlink is never awake this early. I mean, Protost is never awake this early in the morning. Unless, you know, he has responsibilities. Wait, that doesn't do anything. This shouldn't be hard. That's so fun. Okay. Oh, right. 30. I came up with a simple example. So the numbers that I'm getting out by doing the convolution by hand are actually the numbers that I'm getting out by doing the convolution with the FFTs. That's promising. So the next question is that element correct? Okay. If I flip B, 7 should end up in the same spot. That's the flip of B, if the origin's at the center. What if the origin is here? Protost is amazing at this stuff, and I'm trying to do it without him. Okay, so if this is the origin, oh, I'll take the dot product of A and the search shift of flip B. What just happened? Protost is watching my stream. Protost says I reposted a link to the stream so my audience will be huge. Oh, I don't doubt it. I don't doubt it. Protost reposted a link to my stream while flying on a plane using internet through satellites in outer space, which is absolutely astounding. This is super fun. Okay, so I think the center element, the element at the origin, should be 86. Oh, I didn't put the C. That was the issue. Okay. Because that's when the two origins line up. Here, the origin of A is the 3. The origin of B is the 9. The origins line up. We'd take the dot product of those two things. The origin of flipped B is the 9, or the same thing. Take the dot product of A with the flipped B, so it's going to be the dot product of 1, 2, 3, 4, and 7, 10, 9, 8, and then that answer should be 86. Okay, so what do we get when we use the FFT to do stuff. I don't expect this to work. But it did. 86 is at the origin. Oh, or there are two 86s. Okay. Two 26s. Okay, we finally have unique numbers. Okay. Would you mind closing the door?
Oh, you don't want me in here?
Oh, that's fine. But I'm streaming right now.
Oh, no.
Daniel's watching me from a plane using Starlink internet.
That sounds cool.
Protost has indeed had tweets that have received 200,000 views or more. That's impressive. Most certainly. I never did figure out how to tell how many people are watching the stream. 1! Nice. Wait, 1? I'm sure that count is wrong. Okay, back to this. Okay, so the 28 is in the wrong location. I thought that would be the case. Now, wait, sorry. This is me doing the operation by hand, so 28 is the value at the origin, but when I do it using the FFT, 28 is in the first element. Instead of the original element. That's what we got to fix. Okay, so I would have thought that this would, oh, I keep doing the wrong one. I would have thought that would work, and it did. The 28 is at the origin element. Great. Okay. Protoss, maybe it'll go the other way. Maybe, well, I guess that's impossible. I was thinking maybe your audience would grow with all of my followers. I'm thinking that might be right. Okay, so then I'm thinking that the issue might be it's not the convolution, which I'm guessing is correct right now, and it might be the adjoint. And the adjoint is going to be from the flip, but all of these things are odd. The flip, we only need the circ shift when A or B are have even numbers of elements. If they're odd, the flip does the right thing without a circular shift needed. So I am going to have to fix this. I'm just going to put a to-do note for here later. We're both going to be influencers. That's the dream, Daniel. The dream is not to actually get this working, but just to be an influencer. Okay, I put in a simple check to see. Ah. But of course, it's impossible for you to gain followers because we haven't linked to your accounts anywhere. Is it possible? Like, can they click on your name and see your accounts? This is how well I social media. I have no idea how to use any of this stuff. So can I click on Protost name? I can follow Protost. Okay, I am now following Protost, but I don't see Protost is offline. Little do they know. They just mean you're not streaming. About. We don't know much about them, but we're sure Protost is great. They have no idea. Oh my gosh, Protost, you have 5, count them, 5 followers. Ah, there we go. There we go. Now all of my followers can follow you on X. He's at singularitarian. You have 5 followers on Twitch. Okay, back to work. Okay. Let's see if we can make a simpler example. Simpler code. We're going to do one-dimensional circular convolution. Surely we can make that work, right? Right? This is like quals at Stanford. Protost, if you were to stream, 5 people would get notifications. That'd be amazing. Okay, so I'm thinking of these things now as one-dimensional arrays. So NA is equal to numL of A, and K is equal to numL of K. So if you pass in a multi-dimensional array into this code, it's going to treat it as a one-dimensional vector. It's just going to treat it as a vector. Circ shift does what I think. Okay. I'm guessing that's what this was doing, this test. This semester in machine learning class, I'm going to teach building a language model from scratch. I hope you don't need circular convolution. That would be intense. I genuinely think a large language model might be easier. This shouldn't be hard, by the way. this check adjoint function, which I created, is in the work lib library, accepts a function, either accepts two functions that each accept one argument. So for this circular convention, circular convolution, I really like using the FFT. The screen is small. So I'm trying to use the FFT, yes. And I'm trying to check that circular convolution is and its adjoint satisfy the property. Check adjoint satisfies this property. AX or F of X, Y, the inner product of F of X and Y is equal to the inner product of F and the adjoint of Y for all X and Y. So that's what check adjoint does. It just chooses a whole bunch of vectors and checks if that property holds. Too many input arguments to what? I'm confused. So F here, F in, takes two arguments, right? So why is it giving me this error that at line 56, let's see, line 180, line 71. F is F in of X with no transpose. F in does indeed accept two arguments. Does circular convolution 1 accept 3? No. That's the issue. Too many output arguments. Cert column 2. Okay, so now it's running, but it's telling me that the adjoint test failed. Maybe I believe that. Okay. These values are real, so conjugate's not doing anything. We don't have to worry about that. Check adjoint. K is not even going in. That was at least a problem. Getting closer. It's always good to actually, for the function to actually use the input that's getting passed in. That's a good thing. All right. So the question is circular convolution broken? Or is the adjoint broken? So what I'm going to do is just do the circular convolution by hand. We're not going to check the adjoint. So that's giving me these values, and that's fine. Now the question is, are those the same values that we would get if we were to do convolution using flip and shift? Okay, I think I've done it by hand. Array indices must be positive integers or logical values. Oh, right. And they're different. So this first column is the result of the f of t. And this next column is what I get if I do it by hand. Oh, wait, okay. So 30 is at the origin by hand and 28 is at the origin using f of t. Which one is correct? If I look at A, it's 1, 2, 3, 4. If I look at K, it's 1, 2, 3, 5. If I look at flip K, it's 5, 3, 2, 1, and that's incorrect because 3 should have been, the origin's at 3 and it should not have moved. Why did it? Oh, because flip K, I see. Because flip K was just the output of the iteration. So now if I look at flip K, 3 is indeed at the origin. That's right. Okay, so if I take the dot product of A and flip K, I get 28. So it should be 28 at the origin. So it looks like the F of T is correct, and the by hand is incorrect. Test failed. Oh, right. Of course it failed. We knew that. Um, but that confuses me. Oh, I'm putting the origin, I'm storing the values, insert conv AK by hand and with the origin at the first element. So now I got to shift that. And sure enough, they line up. Okay. So this indicates to me that the circular convolution is working. Now here's a question, do we actually want dot product here? Because the dot product with complex values conjugates the complex values of the second argument. I think it's called conjugate linear. Dot product is conjugate linear. When we're doing convolution, circular convolution, do we conjugate the values or not? I think the answer is no. So I'm going to do sum of pointwise multiplication. That should still work. Sure enough, the convolution test passed. Now, if I A is equal to rand Those look the same, don't they? The test passed. Okay, so now it's working with complex values. Now I can change this test to be any size. So if I make it 8, breaks. Horizontal concatenation are inconsistent. Why did that break? That's 8 by 1. Oh, it broke because I wasn't doing enough convolutions. Now the answer is that it passes. What if I made them different sizes? Arrays of incompatible dimensions, of course, because now we've got to zero pad. First argument must be text of pad. I see. Convolution test failed. It's off by 1. And I think that's because we only do the circ shift let's see, n is the size of k. All right, let's see if I broke what I broke. Let's go back to m equals 8 and m equals 8. Now the test passes. So I think this is actually progress. If m equals 9 and n equals 8, then the test fails. M is the size of A. Is there padding of data in here? Right, so we wouldn't want to pad the data prior to doing circular convolution by hand. Now it passed. Now it passed. And is that because I only did, what did I change? Oh. No, n is not the size of k. Okay, okay, okay. Hold on, hold on. Yeah, okay, this is what I changed. Before n was here was before numlk here was n, but now numlk. Uh-oh. Looks like something's happening with my stream. Is it? All right, so maybe something's just happening with my stream on the phone because it's running low on batteries. Okay. Things are passing. I don't remember changing cirtconv1 at all, but the adjoint test fails. So the problem now seems to be with the adjoint. And what is that problem? I'm doing the circ shift all the time. Is there an is even? I created an is even. With circular boundary conditions. Why is there circular boundary conditions? Well, that looks broken. No, that didn't do it. They're both even, so this is going to be called either way. The reason the origin is important with circular convolution or convolution in general is that it's with the flip. The flip flips about the origin. The location in the origin does not move. The location at the origin. Cross correlation is convolution with the second argument flipped. I don't conjugate. Or do I? No. I don't know if I do or not, but that didn't fix it. So let's see. Oh, because I was thinking of it as in terms of yeah, right. Because if we go back to what we did yesterday, the adjoint of a matrix is a conjugate transpose. Circular convolution is just a circular matrix. And so we would have to conjugate its values before doing the convolution. Okay. Okay. We seem to have circular convolution working. So that's at least good. Right. The issue is that, okay, so first we've got the test for cirtconv1 and dwarglib, but cirtconv1 only lives in this local directory. So we won't commit the change in test dwarglib until we've completed cirtconv1 and put it into dwarglib. The way we figured this out for cirtconv is by doing a convolution by hand and then comparing it to the result of cirtconv1. I could do that for the adjoint. I could create the matrix for the circular convolution, take its adjoint, and then multiply that times K. You know what? Right. And maybe that would tell me something. We could compare okay. I want to be doing SPIRiT, but instead I'm doing circular convolution. That's what we'll do the next time we stream. Special thanks to Protost, who was watching me using Starlink internet. Absolutely astounding. All right. See you guys next time.